Writing the terms of a sequence defined by a recursive formula. Sequences occur naturally in the growth patterns of nautilus shells, pine cones, tree branches, and many other natural structures. We may see the sequence in the leaf or branch arrangement, the number of petals of a flower, or the pattern of the chambers in a nautilus shell. Their growth follows the Fibonacci sequence, a famous sequence in which each term can be found by adding the preceding two terms. The numbers in the sequence are the following. We have 1 and 1. If we add 1 and 1, we get 2. If we add the second term and the third term, 1 plus 2 gives us 3. If we add the third and the fourth term, 2 plus 3 gives us 5. If we add the fourth and the fifth term, 3 plus 5 gives us 8. 5 plus 8 gives us 13. 8 plus 13 gives us 21. And 13 plus 21 gives us 34, and so on. Other examples from the natural world that exhibit the Fibonacci sequence are the Kaya lily, which has just one petal, the black-eyed Susan with 13 petals, and different varieties of daisies that may have 21 or 34 petals. Each term of the Fibonacci sequence depends on the terms that come before it. The Fibonacci sequence cannot easily be written as an explicit formula. Instead, we describe the sequence using a recursive formula, a formula that defines the terms of a sequence using previous terms. A recursive formula always has two parts: the value of the initial term or terms, and an equation defining a subscript n in terms of preceding terms. So for example, suppose we know the following: a subscript 1, that is the first term, which is equal to 3. And we can see that the nth term is equal to 2 times a subscript n minus 1 minus 1 for when n must be greater than or equal to 2. So we can find the subsequent terms of the sequence using the first term. Again, the first term is 3. So the second term is going to equal 2 times the preceding term, which is the first term, minus 1. So 2 times 3 minus 1 is going to give us 5. Now the third term is going to equal 2 times the preceding term, minus 1. Well, the preceding term is 5. So therefore, 2 times 5 minus 1 is going to give us 9. The fourth term is equal to 2 times the preceding term, minus 1. Well, the preceding term was 9. So now it becomes 2 times 9 minus 1, which is equal to 17. So we can say that the first 4 terms of the sequence are 3, 5, 9, 17. Now the recursive formula for the Fibonacci sequence states that the first two terms, the first two terms and defines each successive term as the sum of the preceding terms. So the first term is 1, the second term is 1, and then the nth term is taking the preceding term plus the second term for all n being greater than or equal to 3. Now, to find the 10th term of the sequence, for example, we would need to add the 8th and the 9th terms. We were told previously that the 8th and 9th terms are 21 and 34. So a subscript 10 is going to equal the 9th term plus the 8th term. So that's 34 plus 21, and therefore the 10th term is going to be 55. So the definition of a recursive formula. A recursive formula is a formula that defines each term of a sequence using preceding terms. Recursive formulas must always state the initial term or terms of the sequence. Q&A. Must the first two terms always be given in a recursive formula? The answer is no. The Fibonacci sequence defines each term using the 2 preceding terms, but many recursive formulas define each term using only 1 preceding term. These sequences need only the first term to be defined.